Alright, today I'm going to discuss about this function questions. This kind of function question actually is quite common for IGCC student, but it's quite new for the SPM student. So I decided to make a short video to discuss about it. So let's go through this question together. Fx equals to negative x squared plus 6x minus 5 is defined for x is bigger or equals to m, where m is a constant. State the smallest values of m, which f is 1-to-1 relation. Alright, okay, basically we know about this quadratic equation. When we see the coefficient of x squared is -1, it's a negative graph. So we know actually we will get a graph look like this. Alright, and then if you know about this is the n shape of the quadratic curve, you know it's not possible to have the 1-to-1 relation because this one, if I make a y value like this, any y value, I will get two x value within it, x1 and x2. Okay, let's say, yeah, I just make any y value, then I have two x value into the one y value. So this kind of curve we call many to one, because we have many x value go into one y value, we call many to one, which is not 1-to-1. So now the question is like, how can we make this curve into the 1-to-1 relations? So yeah, so this is what I want to discuss today. So if you see carefully about this kind of curve, at least you will know something. If I have a curve like this, in order to make it become the 1-to-1 relation, what I will do is I will just like split this curve into half from the maximum point or the minimum point, depend is u or n. So imagine if I split like this, so I can take like either my right hand side or I can take from my left hand side. Because imagine if I cover my left hand side here, that means if I cover the whole thing here, you can realize on the other side here is basically 1-to-1 function, isn't it? Because from here to here is actually 1-to-1 function. Alright, so same ideas to, okay, if I cover my right hand side here, if I cover everything on my right hand side here, you can realize my left hand side over here, the curve actually is 1-to-1 relation, isn't it? So this is how actually we make the function fx into the 1-to-1 relations. Yeah, so yeah, this kind of case is very common for the quadratic equation. Means you will see your the highest power of x squared is basically 2, which is called quadratic equation. It's very common for quadratic equation because for quadratic equation you can easily make it into 1-to-1 by split the curve from the maximum or minimum x value. Alright, but then we have another keyword, is the smallest. Okay, so let's have a look on this question quickly. Let me just erase this thing first. Okay, so what you can do is, there's two ways you can do. One, you can do the completed square, or you can do the dy dx, or maybe I show you both. Okay, so I do the completed square first. So okay, so my fx is basically equals to, I factorize out my x negative, so I get negative 6x minus 5. Alright, so if I do the completed square here, I will have x squared minus 6x. Maybe I shouldn't use the bracket yet. Okay, so I get x squared. I have one bracket definitely. Minus 6x plus something square minus something square, isn't it? Then minus 5. The something here is basically b divided by 2, which is negative 3. This one will be negative 3. Then we combine the first 3 terms, isn't it? So we get x minus 3 squared. And then this one will give me minus 9. But I will multiply the negative into it later. Alright, so this one I multiply negative into both. When I say multiply for the first bracket, I just leave outside the first bracket here. And then negative multiply for negative 9, I get positive 9. Positive 9 minus 5, I get positive 4. Okay, so from here, at least I know my value is like this. The highest one, this one should be 3 and 4. Alright, so if I want to make this one into the 1-to-1 function, what I can do over here is, actually I can split from the line axis symmetry, right? X equals to 3. So because over here you realize your range given is bigger or equal. So bigger or equal basically indicates I must take this side, because I need to make sure my curve actually is going this direction, because this is bigger, right? If less than, then I will make sure my graph is actually going the other direction. So why does the question say smallest? Because it's like this. This line is called x equals to 3. Okay, this one will be the smallest. That means actually I can cut the curve like this, which are using x equals to 4. Or I can cut like this, x equals to 5. And so on. Because if I cut x equals to 4 here, my curve over here is still 1 to 1. Do you see that? If I cut the curve x equals to 5, my curve over here is still 1 to 1. So that means even though I can do something like 3.1, 3.2, 3.4 and so on, but then the smallest one definitely is 3. And you not believe me, you might think, how about 2? If I cut like this, example, just x equals to 2. This is not 1 to 1, because if I sketch out the thing, it will look something like this. That means over this part over here, you still touch 2x value, isn't it? So it will not be the 1 to 1 if I cut like x equals to 2. That means I cut from here, let's say x equals to 2. Then this curve is not 1 to 1. So therefore the minimum value, or we call it smallest value, to make this curve into the 1 to 1, you basically must cut at the maximum or the minimum point. Depend on your curve. This one is the N curve, so it will be maximum point. If the U curve, then you will go to the minimum point, the x value of the minimum point, in order to make it into the 1 to 1. Right, so in this case, what is your M value? Your M value is just 3, because this one will be the smallest M value. Just now I said I will show you two methods, right? So the second method is basically you can do using the dy dx. So therefore, I will just, because no matter smaller or bigger, we differentiate it, equals to 0, isn't it? This one is negative 2x plus 6 equals to 0. Then 2x equals to 6, then x equals to 3. So you realize differentiation is always faster. Alright, so basically I get my minimum x value. So therefore I know basically I need to cut from the minimum value, right? So my x must be equals to 3. The value 3 here. So therefore my m must be equals to 3. Alright, so yeah, this is how I do this kind of questions. I hope this short video can help you understand how to make the quadratic function, into the one-to-one relations. Alright, so yeah, I hope you like this video. Anyways, if you have any question, please post at the comment below. Yeah, I will see you guys in the next video. Bye bye.